Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. We will be presenting on testing conventional application.
So there are several characteristics that lead to a testable software. First is observability. The result of each test case are readily observed. Second, controllability. The degree to which testing can be automated and optimized. Third, decomposability. Testing can be targeted. And fourth, simplicity. Reduce complex architecture and logic to simplify the test. And next, stability. A few changes are requested during testing. And lastly, understandability of the design. So, how we want to consider a good test? So, actually, a good test has probability has a high probability of finding an error. A good test also is not redundant and should be best of breed. A good test also should be neither too simple or not too complex. So in testing, they are divided into two, which is external that we call black box and internal that we call white box. So for external or black box is knowing the specific function that product has been designed to perform. Tests can be conducted that demonstrate each function is fully operational, while at the same time searching for errors in each function. For internal, knowing the internal working as of a product, tests can be conducted to ensure that all gears match. This is internal operation are performed according to specification and all internal components have been adequately exercised.
Assalamualaikum, my name is Muhammad Khalil Azmi. So I'm going to continue to about the exhaustive testing topic. So what is exhaustive testing topic? Exhaustive testing. So it's a testing that an application, validating application with all possible scenario. So to make sure that the application cannot be destroyed or crashed by some random happening. So after finish the testing, this application after an application passes the testing, it, it can be said that the application is the most perfect and robust application. So to explain it more deeper, more clear about the exhaustive testing, we take example of application which accept the password with 4 character input with consecutive repeated entry. And each input accept have possibility of 256 character. So this 4 input we time 256 four time. So and we will get a 4 billion around 4 billion combination. This 4 billion combination will take 11 minute hour to solve, 497,000 days to solve, and 1,361 years just to finish up just to finish up test all the combination. So it can be conclude that this exhaustive testing is impractical and impossible for big applications such as this application. So next is the whiteboard testing. So whiteboard testing basically used to verify flow of input output and to improve design, usability and security. In this testing, the code will be visible to the tester. So the goal of the white testing are to exercise all program logic path within a module at least once and exercise all logical decision on their true and false side, and to check all internal data structure boundary to ensure their validity. So this testing focus on the program control structure within a single module. And what do we verify in the whiteboard testing? We verify the internal security hole. We test the security system of an application. Is it easy to hack this application or not? And the tester will also test the coding structure. Is it broken or poorly structured path in the coding process? And the other thing that we verify is the flow of the specific input through the code or expected output. The tester also will verify the functionality of conditional loop and testing of each statement statement, object, and function on an individual basis. So this testing can be done at a system integration and unit level of software development. So here is the one of the technique of the white box testing technique called basis path testing. So basis path testing was proposed by the Tom Eckert, and this technique enable the test case designer to derive a logical complexity measure of a procedural design and use this measure as a guide for defining a basis set of execution path. So before we go further into basis path testing, I will introduce to you to the flow graph notation. So what is flow graph? Flow graph. So here we have a flow chart in the left side and flow graph on the right side. So the difference between the flow graph and the flow chart is that flow graph do not show the detail of what is in a process block, but flow chart draw every part of the process block. And in the flow graph, we only use one type of symbol to represent a node. But however, in the flow chart, we use different type of node. We use a different type of symbol, as we can see in the figure. And flow graph, it focus more on control flow of the program. However, in the flow chart, it focus on the process step, and because of that it is not suitable to it does not and because of that it does not use for testing. So there's four things that we need to know in the flow graph. First is the node. Node is used to represent the procedural statement. So here the second one is called a node, and the second one is edges. Edges is the arrow that indicate the flow of the flow graph. It represent the flow of the control of the flow graph. And the third one is the region. Regions are the area bounded by the node and edges in the flow graph. So if we can see here, this area is bounded to the node and edges. So it's considered to be regions. And regions outside and area outside of the flow graph is also included as a region. And the last thing is the predicate node. Predicate node is a node that represent the condition statement, and it can be characterized by two or more edges coming out from a node. So we can see here in this node there has 3 edges coming out from it. So this node is considered to be a predicate node because there's there are 2 or more edges coming out from it. So here is the technique of the basis path testing. It calls an independent program path. So an independent path is any path through the program that introduce at least one new set of processing statement or new condition. So here, if we take the previous previous flow graph, we can have a 4 path. However, it's kind of difficult because we have to find one by one possible path using this technique. But there is another easiest ways to find the independent path. So called cyclomatic complexity. Here is a software metric that provide a quantitative measure of the logical complexity of a program. So and it has three way to compute it. So the first way, we calculate number of region of the flow graph. So here we can see that we have 4 region. So the total path in the flow graph is the total path in the flow graph is 4. We will get 4. And there's another method we use equation Vg equals to E minus N plus 2. So E is the total number of edges, while N is the total number of node. So in the flow graph here, we have 9 node and 11 9 node and 11 edges. So 11 minus 9 equal to 2. 2 plus 2 equal to 4. So same as we calculate using a region. So another and the last method the last method he use is VG equals to P plus 1. So P is the total number of predicate node contained in the flow graph. So as I explained before, predicate node is the node that characterized by two or more edges coming out from it. So, in the flow graph here, we have three three predicate node. So this node 1, node 2, 3, and node 6. So 3 predicate node plus 1. So we get 4 total paths. So using this complex cyclomatic complexity is much easier to calculate the total path if we compare with independent program path. So that's it for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat Syahmi bin Zamari. I will be presenting on deriving test cases. The basis path testing method can be applied to a procedural design or to source code. We present basis path testing as a series of steps. The procedure average will be used as an example to illustrate each step in the test case design method. Note that even though procedural average is an extremely simple algorithm, it is also contains compound condition and loops. The following step can be applied to derive the basis set. Using the design or code foundation, draw a corresponding flow graph, determine the cyclomatic complexity of the resultant flow graph, determine a basis set of linearly independent paths, prepare test cases that will force execution of each path in the basis set. Graph matrix. A graph matrix is a square matrix whose size is equal to the number of nodes on a flow graph. Each row and column correspond to an identified node, and matrix entries correspond to connection between nodes. By adding a link weight to each matrix entry, the graph matrix can become a powerful tool for evaluating program control structure during testing. This is a figure of graph matrices. As we can see, on the left is a flow graph and the right is a graph matrix. We can change flow graph to graph matrix. As you can see, the flow graph have 5 nodes. We need to make a 5 times 5 graph matrix, and then we fill the graph matrix with a path from 1 to 3. They are A, and 3 to 2, they are D. So we fill the graph matrix with the corresponding path. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fauzan bin Muhammad Asali with metric number 1717339, and I will be presenting on control structure testing. So in control structure testing, it is a method to increase the coverage area by testing various control structure present in the program. So what we want to do here is we want to control what will be tested on, like the variable that is used in the testing. And then in control structure testing, there are 3 types of testing under it. The first one is condition testing. And then we have data flow testing, and then we have loop testing. So in condition testing, it is a method where we want to ensure the condition is logic and the decision statement are free from error. Examples from condition testing is like when we want to declare a variable. For example, in our coding we have x equal to 1 or x why. So that types of condition needs to be condition testing in order to avoid error on the variable or on the arithmetic expression. Other than that, we can also do a testing on any relational expression such as in an operator in coding or the use of or operator in coding. So next, the second testing is data flow testing, which is a method to choose the test path of a program based on the location of the definition and uses all variable in the program. So in here, what you want to know is regarding to the variable that is used. So what we want to know here is we want to see where is the variable is being used and what are the value will be received in the variable. So we can see in the example in the right side where we have let x and y, we have if x more than y. All of this can be seen like not only on the earlier of the coding but maybe in the middle or in the last part. And the advantages of data flow testing is we can find the variable that is used and that has been defined, and we can see where is the variable that we use, and how you can also see where how many times it has been used. And then there is a disadvantages of data flow testing is it is time consuming and sometimes it costly process, and also it require knowledge of programming languages. And now we move to the loop testing, which is the last testing under control structure testing. So in here, loop testing is actually a white box testing. It focuses on looping or repeated repeated method. So in the first one, under loop testing is a simple loop where first it has its initialization, and then as it goes in under the condition, it will see if the initialization is true or false. If it is true, then it will be looping all over until the initialization, maybe it is increased or it is decreased or anything until it meet the false condition, and then the loop will be ending. And then on the next type of loop is nested loop, where we have a loop inside a loop. So what we this the the looping inside need when the loop goes inside a loop, the inner loop will have to finish its repeated or looping until it went outside. And if the outside is not finished yet, it will go back into the inside and loop again until the outside looping condition are satisfied, and it will end all the loop. And then the last loop is concatenated loop, or it is also can be called a series of loops, where it has a loop after a loop. So after a loop is satisfied, and then it goes to another loop, and then it will be looping and until it satisfies, and and it finish the loop. So that's all from me about control structure testing. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahidul Rahman and I will continue blackboard testing. Blackboard testing, also known as behavioral testing, it is a software testing method in which the internal structures or design or implementation of the item being tested is not known to the tester. Blackboard testing tends to find errors in the following categories. Number one, incorrect or missing functions. Number two, interface errors. Number three, errors in external database access. Number four, behavior or performance errors. And lastly, initialization and termination errors. Blackboard testing are designed to answer the following questions. Number one, how is functionality validity tested? What classes of input will make good test cases? Is the system particularly sensitive to certain input values? How are the boundaries of data isolated? What does data reach and data volume can the system tolerate? What effect will specific combination of data have on system? By applying box technique, you will derive a set of test cases that satisfies the following criteria. Next, we go to graph-based model testing to understand the objects that are modeled in software, and the graph-based testing is to understand objects that are modeled in software and the relationships that connect this object. Now we go to the diagram at the right. There is nodes. The circle one are represented as circles connected by links that take a number of different forms. Then we have three types of link: directed, undirected, and parallel links. Directed links indicates that a relationship moves in only one direction. And this one. Then we also have a bidirectional link, also called symmetric link, and not shown here. It gives the relationship applies in both directions. Next, we have parallel links here. Parallel links. Parallel links are used when a number of different relationships are established between graph nodes. In this context, we consider the term of object in the broadest possible context. It encompasses data objects, traditional components, and object-oriented elements of computer software. Next, we go to the partitioning equivalence. Partitioning equivalence is a blackboard testing also. It is a method that divides the input domain of a program into classes of data from which test cases can be derived. Equivalent classes may be defined according to the following guidelines. Number one, if input condition specifies a range, one valid and two invalid equivalence classes are defined. Number two, if an input condition requires a specific value, one valid and two invalid equivalence classes are defined. Number three, if an input condition specifies a member of a set, one valid and one invalid equivalent class are defined. Lastly, if an input condition is Boolean, one valid and one invalid classes are defined. All right, now we go to the BVA. BVA leads to a selection of test cases that exercise bounding values. BVA is a test case design technique that complements equivalent partitioning. Rather than selecting an element of an equivalent class, BVA leads to the selection of test cases at the edges of the class. Rather than focusing solely on input conditions, BVA derive test cases from the output domain as well. That's all from me. Thank you.
Orthogonal array testing can be applied to a problem in which the input domain is relatively small but too large to accommodate exhaustive testing. Used when the number of input parameters is small and the value that each of the parameter may take are clearly bounded. The orthogonal array testing method is particularly useful in finding region faults and error category with associated faulty logic within a software component. The orthogonal array testing approach enables you to provide a good test coverage with far fewer test cases than the exhaustive strategy. So, so there are several faults that we can find using orthogonal array testing. And first is to detect and isolate all single mode faults. Second, detect all double mode faults. And third, multi-mode faults. So for model-based testing, there are there are several steps in using a model-based testing. So actually, model-based testing is the black box testing technique. So first, we must analyze an existing behavioral model for software or create one. So we have to recall that the behavioral model indicates how software will respond to external event or stimuli. Second step is to traverse the behavioral model and specify the input that will force the software to make the transition from state to state. So actually the input will trigger event that will cause the transition to occur. So we have to identify all of these. So for the third step is to review the behavioral model and note that the expected outputs as the software makes the transition from state to state. So what this means is we have to review the model. We have to see um, what trigger from this page or to next page, or what trigger if you do this action in the software, what is the next action. We have to identify our step. So the fourth step is to execute the test cases and see the result. And fifth, compare the actual and expected result and take corrective action if as required. So we have to make and finally we have to make some adjustments in this model-based testing. So for the software testing patterns describe a common testing problem and solution that can assist you in dealing with them. Testing patterns are described in much the same way as the design pattern. Dozens of testing patterns have been proposed in the literature review. The following three testing patterns presented in abstract form only provides representative examples. So first we have pair testing, second separate test interface, and third we have scenario testing. So for example, I only give you one here, which is scenario testing. So in abstract, one unit and integration test has been conducted. There is a need to determine the whether the software will perform a manner that satisfies users. The scenario testing pattern describes a technique for exercising the software from the user point of view. A failure at this level indicates that the software has failed to meet the user visible requirements.
In short, exhaustive testing is impractical and impossible testing. Cyclomatic complexity is a useful metric for predicting those modules that are likely to be error prone. Use it for test planning as well as test case design. So the higher the VG, which is the complexity, the higher the probability of error. The basis pass testing method can be applied to a procedural design or to source code. We present basis pass testing as a series of steps. The procedure average will be used as an example to illustrate each step in the test case design method. A data structure called a graph metric can be quite useful for developing software tools that assist in basis path testing. Loops testing can help to identify loops initialization problem, and it show up mostly in low-level software. Black box testing techniques. Testing focus on the information domain of the software, deriving test cases by partitioning the input and output domain of a program in manner that provides true test coverage. Equivalence partitioning divides the input domains to classes of data that are likely to exercise a specific software function. BVA probes the program's utility ability to handle data at the limit of acceptability. That's all from our group. Thank you.